Welcome Science 10. We're going to look at the Blackline Master 9.5a average speed handout and work through it, point out the formula that we used to figure out average speed, and look at some of the units, and then look at converting from meters per second to kilometers per hour and vice versa. So first of all, average speed. If we look here, here is the way we can use the idea of average speed. V with a little subscript AV is referred to as average speed. Okay. The triangle that you see here is actually the Greek symbol delta, which means change in. So it's the fourth letter of the Greek alphabet. That's what we use to describe that. Delta D is change in distance or distance, just in general. It can be figured out by using a final position minus initial position, and you'll run into that more when you take physical science or physics 30. And of course, delta T is change in time or elapsed time. And if you look over here, some of the common units we use for distance: millimeter, that's used if we're talking about something that's really small moving, such as an ant. Centimeters, or most of our questions are going to involve meters or kilometers for bigger distances. Time, the main units we'll be using there are seconds and hours. And using those common units, we'll have meters per second for speed, such as what you would measure in the hallway, how fast you're running there, or kilometers per hour if you're traveling by car. So if we scroll down here, look at an example here. Kyra is trying to predict the time required to ride her bike to the nearby beach. She knows that the distance is 45 kilometers. So we can pick out distance from that. And from other tips that she can average about 20 kilometers per hour, which is speed. Predict how long the trip will take. So we're asked to find time. So notice, as you're reading through that, pick out the variables that you know and the variable that you're looking for. Now in this particular case, we're not asked to find speed, we're asked to find the time required to travel. Now we have this equation up here, which I'm just going to rewrite here. VAV for average speed equals change in distance over change in time. And we're actually asked to determine what that is. And it's in the denominator of the equation. Now there's a real easy way we can figure that out. A little schematic here that I'm going to draw. It's a little triangle or a pyramid, you can think of it as. And if we arrange it like this, VAV equals D over T, we can solve for any of those three variables and automatically come up with the right formula. So V, if I'm looking for V, it's D over top of T, or over top of really means divided by. V is equal to D divided by T. If I was looking for T, like I am in this example, we can see T is equal to D over V, D divided by V. So if I was looking for T, delta D over V AV. And the last option I could have here is if I'm looking for D, we could see V and T are side by side, so that would mean multiply. So if I was looking for D, it's VAV speed multiplied by T. So that's a really easy way you can use to rearrange that formula around. So I call that triangle of terror or pyramid power, whatever one you want to use. Now in this case, I'm looking for T, so I'm looking for the equation that uses T. So that's definitely that one. And you can see that's how this equation was arrived at. Okay? And lastly here, one final note, so they have two different ways. So you can either rearrange the formula first, then put the numbers in, or put the numbers in first, then rearrange it. It doesn't really matter which way you do it. But one final thing to note that we've touched on before is how to convert speed of meters per second to kilometers per hour. And the magical number there is 3.6. So if you have so many meters per second, and if you want to go to kilometers per hour, you multiply by 3.6, and that'll give you your answer in kilometers per hour. So that little lab that you did in which you figured out the speed you could run at, we calculated it in terms of meters per second, then converted it to kilometers per hour. Or vice versa, if we have a speed value in kilometers per hour, to change to meters per second, we divide by 3.6, and that'll give us our units in meters per second.